So yesterday I completed that matrices, right, first unit, and we are left with one more, that is eigenvalues and eigenvectors. Okay, as machine learning people want some topics of probability, so I thought of starting probability first. Okay, so in this I'll try to cover maximum topics today. It is not at all possible to cover all the topics of probability in 3 hours class, as you all know, right. So it consists of around 5 to 6 units, but I'm not going that much deep. Just I'll brush up all the topics and I'll make you do the questions on that, right. So even then it's not at all possible to complete all the topics in 3 hours class. So today I'll try to cover maximum topics of this, and tomorrow I'll try to take 3 plus 2 hours, because maybe for 2 hours I'll continue with the probability topics, and in the next 3 hours I may take eigenvalues, eigenvectors, singular value decomposition and all. I'll see, if possible I'll take those 2 hours. If not required, then I'll try to cover all the topics in the morning session only. Okay, tomorrow. So today, yes, first of all we'll see the probability. I already discussed with you yesterday that we are not going into deep in all the problems of probability. Okay, I'll try to cover up to maximum extent. Okay, but doing many problems is not at all possible. Do you remember what are the topics we had in the first unit of probability, or roughly? Okay, so just I'll give a brief, listen fast. Okay, so we had what is a probability. Okay, before going to that, what are the events, what is nothing but a sample space, right, what are the different types of events, what is a random experiment. Okay, and you had even addition theorem, multiplication theorem, dependent independent events, Bayes theorem, conditional probability. These were the topics in the first unit of probability, right. So just I'll give a brief of all those things. Okay, what is a sample space? Sample space is nothing but the collection of all the outcomes, right. Then a finite subset of that sample space is called as an event. Getting even numbers when a die is tossed, getting odd numbers when a die is tossed, getting getting all the numbers more than 4, and so on. They are the finite subset of the sample space. We know that when a die is tossed, what will be the outcomes? 6, 1, 2, 3, 4, 5, 6. Now see that when I am saying that when a die is tossed, what is the event of getting even numbers, right. So it is a finite subset of the sample space. It takes 2, 4, 6, right. It's a part of that sample space. So a finite part of the sample space is called as event, right. So in that we have learned different types of events. Equally likely events, when all the events are equal, or if all the events have same chance of happening, same chance. Okay, if they have equal preference, then they are said to be equally likely. Okay, like when a coin is tossed, getting head, getting tail, they have the equal preference. So such events are called equally likely events. Then mutually exclusive, if one happens, the other will not happen. When I toss a coin, then I'll get head or I'll get tail, both will not happen. So one prevents the happening of the other one. So such events are called mutually exclusive events. Mutually exhaustive events means out of this only you will get the outcomes, it will not be beyond that. Exhaustive, total number of outcomes in any trial, that will become exhaustive events. Okay, then we have learned about certain event or sure event or impossible event, null event, right. Certain event or sure event, in the word itself you have the answer. Certain, sure means the event which always happens is called as a sure event or certain event. there is no uncertainty, right? Impossible event, null event, the event which never happens is called as an impossible event, right? So we have learnt about all these events. Then we have learnt about the probability. What is probability? Okay, if the random experiment results in all these, that is mutually exclusive, exhaustive and equally likely events of the sample space, and among them only m are favorable for happening of the event T. How we define the probability? Favorable number of cases by total number of cases. Probability of any event is defined as favorable number of cases for happening of that event T by total number of cases. That is defined as the probability, right? And we have learnt about the axioms of probability, that is P of E, probability value will always lie between 0 and 1. And we have learned that sum of the individual probabilities equal to 1, sum is equal to 1, it will not go beyond that, right? And you have learned that axiom 3, if E1 and E2 are two mutually exclusive events, if one happens, the other will not happen. If one happens, the other will not happen. Then in such a case, P of A union B will be equal to P of A plus P of B. There is no P of A intersection B. Why? Exclusive. There is no common point, because one happens, the other will not happen, right? So most of you will get confused with independent, dependent and exclusive. Okay. Now I'll come to dependent and independent. Thus I'll give the brief of that. Dependent, independent. In dependent and independent, okay, first of all we should know about conditional probabilities. Conditional probabilities. Okay, here both will happen. See the difference. In mutually exclusive, only one will happen, the other will not happen. In this independent and dependent events, or the conditional probabilities or the conditional events, both will happen, but one will happen after the other. If A happens after the event B, or B happens after the A, after the happening of event A, then those events are called conditional events. A by B, B by A. Happening of A after happening of B, happening of B after happening of A. Those are called conditional events, and their corresponding probabilities are called conditional probabilities. Conditional probabilities. Okay. So from conditional probabilities, okay, after that we can learn about dependent and independent events. Okay. If the happening of one doesn't affect the happening of the other, if the happening of event A is not influencing or affecting the happening of the second event, okay, then we can say them as independent. If each one of them has no effect on the others, if A has no effect on B or B has no effect on A, then they are said to be independent of each other. Independent of each other. By default, yes, write down, by default, events will not be mutually exclusive. Events will not be mutually exclusive. According to the sentence, we have to proceed, okay? We have to check. By default, events are not mutually exclusive. Then second, by default, events are not mutually independent. We have to check whether they are satisfying that condition or not. Accordingly, we have to proceed. By default, they will not be there, okay? That is the reason, if you recall, we write P of A union B as P of A plus P of B minus P of A intersection B, right? Unless and until we observe that they are mutually exclusive, we will write the complete formula, that is P of A plus P of B minus P of A intersection B. If we find that, like winning the race, if one wins, the other will not win. So in such a case, I will drop the term P of A intersection B. So default, it is not the case of mutually exclusive, okay? Then these were the just the introduction. Conditional probabilities, okay? Okay, I'll make you write here all those things. Then we have learned about Bayes theorem also, right? So I'll tell that after conditional probabilities and all. Okay. Before going to that, I said that addition theorem is also there. Addition theorem for 2 events, addition theorem for 3 events, but no need to learn the theorems now, just you have to remember those formulae. Okay, and multiplication theorem and problems based on that, conditional probabilities and problems based on that, and Bayes theorem and problems based on that. Even problems on Bayes theorems are being asked in the competitive exams. Okay, we have seen yesterday that Bayes theorems are also asked. Okay, is that introduction enough? Okay, when I deal with conditional probabilities, again I'll make you write the formula, then I'll start. Is for the introduction, do you want still any explanation for starting, just the starting of the probability? No. So shall we start the problems? Okay. Okay, write some problems. Step by step we'll proceed. We'll not do all the problems. Before this, do you remember pack of cards? Can anyone tell me? Pack of cards? Yes, 52. 52 is divided into black and red, right? Black, then red, 26, 26. Then spades, clubs, spades, clubs, then hearts, diamonds, hearts, diamonds. Then these are all 13, 13. What are those? What are the cards? 13. Yes. A, 2, 3, 4, so on. King, Queen, Jack. Right? So these are the 13 cards in spades, clubs, hearts and diamonds. Right? 13 cards will be there, and those are the 13 cards in that. Okay, so I'll write here probability also. Probability is given by favorable number of cases by total number of cases. Then we'll also write the axioms. 0 less than or equal to P of A less than or equal to 1. Then P of S is equal to 1. Then if A and B are mutually exclusive, P of A union B is equal to P of A plus P of B. Yes, then I am writing addition theorem also there. Addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. So first we'll finish problems based on this, then I'll move on to conditional probabilities. Done? Write a note. Probability of at least one is equal to 1 minus probability of none. Probability of at least one is equal to 1 minus probability of none. Probability of at least 1 is equal to probability of none. Okay? And P of A complement is equal to 1 minus P of A. P of A union B, or how you write A union B whole complement? A union B whole complement is equal to A complement intersection B complement, right, by using De Morgan's laws. And A intersection B whole complement is equal to A complement union B complement. So P of A union B whole complement will become P 1 minus P of A union B, and so on. You can extend it. Done? Now we'll start some problems, then we'll go to MCQs. After finishing all the topics, better I'll take MCQs because it covers all. Write the question. N letters to each of which corresponds an addressed envelope. Similar type of question I saw in some competitive exam yesterday. N letters to each of which corresponds an addressed envelope are placed in the envelopes at random. What is the probability that all the letters are placed in the right envelopes? All the letters are placed in the right envelopes. Second bit there. Find the probability that at least one letter will go into wrongly addressed envelope. You are given n letters, n envelopes. Okay? In how many ways you can put them correctly? Only one way. All should go into right envelopes. In how many ways it can happen? Only one time. Okay? N letters are there. You have to put in n envelopes. So in how many ways you can do that? N factorial ways. N blocks can be filled with n letters in n factorial ways. So what is the chance? What is the chance? 1 by n factorial. Favorable number of cases is only 1. Total number of cases is n factorial. So first bit is required probability is 1 by n factorial. Then second bit what is said? At least one will go into wrongly addressed envelope. Just now I told you that probability of at least one is equal to 1 minus probability of none. None will go into wrong addressed envelope is same as all will go into right addressed envelope. Right? None will go to wrong addressed envelope is same as all will go to right addressed envelope, which we already calculated. So the required probability is 1 minus 1 by n factorial. The next. 6 boys and 6 girls sit in a row at random. 6 boys and 6 girls sit in a row at random. What is the probability that 6 girls sit together? Second bit, boys and girls sit alternately. If all the girls sit at one place, right? So what is the chance? 7 factorial by 12 factorial, because 6 girls and 6 boys are there. So total number of students are 12, right? So total number of cases becomes 12 factorial, right? And 6 girls are treated as a single unit and 6 boys are there. So we have altogether 7 units. So which can be arranged in 7 factorial ways. So what is the answer? 7 factorial by, is that right? 7 factorial is when we are taking 7 units. Yes, 7 units can be arranged in 7 factorial ways, but in turn 6 girls can be arranged in 6 factorial ways. So total number of ways are 7 factorial into 6 factorial, favorable number of cases. Total number of cases are 12 factorial. So 7 factorial into 6 factorial by 12 factorial. Then next, second. Boys, girls. Okay, 6, 6. So what is the answer? 2 into 6 factorial into 6 factorial by 12 factorial. How? Suppose you are arranging 6 boys first. 6 boys. And in between you have to make 6 girls to sit. 6 boys can be arranged in 6 factorial ways. And 6 girls can be arranged in 6 factorial ways. Okay? First you made boys to sit. The second way is girls to sit. Right? Again, girls can be made to sit in 6 factorial ways and boys can be made to sit in 6 factorial ways. 6 factorial, 6 factorial, 6 factorial, 6 factorial. So that's the reason you are getting that as 2 times of 6 factorial into 6 factorial divided by 12 factorial. Then next, what is the probability? What is the probability that a card drawn at random from the pack of cards may be either king or a queen? How many kings are there? Total pack of cards are 52, right? So 4 kings, 4 queens. So what you will get the answer? How many cards are drawn? 1. Okay, what is the chance that will get either a king or a queen? What is the concept you are using here? Union. Yes, either a king or a queen. So union. Okay, P of K union Q. P of K union Q. Okay, so P of K union Q can be written as, are they mutually exclusive? Are they mutually exclusive or not? No? Do you have any common? No. King, queen, do you have anything common? No. So you can write it as P of K plus P of Q. P of K plus P of Q. Okay, what is the chance for getting a king? 4 by 52. What is the chance for getting a queen? 4 by 52. 1 by 13 plus 1 by 13, that is 2 by 13. Okay, then next. An integer is chosen at random from the first 200 positive integers. What is the probability that the integer chosen is divisible by 6 or 8? So which concept you have to use? Union. 6 or 8. So P of getting 6, P of getting numbers divisible by 6, numbers divisible by 8. So are they mutually exclusive? Yes. Are they mutually exclusive? No. There can be some numbers which are divisible by both. Okay? There are some numbers which are divisible by both 6 and 8. So you have to use the formula of addition theorem. Okay, write that P of A union B equal to P of A plus P of B minus P of A intersection B. A numbers divisible by 6, B numbers divisible by 8. A intersection B numbers divisible by both A and B. So what is P of A? How many numbers are divisible? How many numbers are there actually? 200. Okay, 200 numbers are there. How many are divisible by 6? 33. So P of A equal to 33 by 200. How many are there divisible by 8? 40? 25. So P of B will become 25 by 200. Now how many are there which are divisible by both? 8. How you are checking that? Take the LCM of 6 and 8 and check with that. Okay, you will get how many are divisible. Whatever the number you are getting of 6 and 8, LCM of 6 and 8, okay, check with that number, 200 divided by that. Okay, so how many you are getting? How many are divisible by both 6 and 8? 8. So P of A intersection B equal to 8 by 200. Then put all those 0.25. Then next, if 3 of the 20 tires in storage are defective, if 3 of the 20 tires in storage are defective and 4 of them are randomly chosen for inspection, what is the probability that one of the defective tires will be included? 3 of 20, okay, are defective, 4 of them are selected at random for inspection, then what is the probability that only one of the defective tires will be included? Actually, I think it should be right, it should be kept under binomial, but okay, try to say. How many are selected? 4. 3C1 into 17C3 by 20C4. Okay. Done? 3C1 into 17C3 by 20C4. Why? 20 tires are there. We are selecting 4. That can be done in 20C4 ways. And he said that only this much to be included. So that's the reason we got 3C1 into 17C3. The next, out of 15 items, 4 are not in a good condition. Full stop. If 4 are selected at random, find the probability that all are not good. Second bit, 2 are not good. How many are there and how many are good? 1 by, how many are there? How many given? 15. Out of them 4 are not good. So 15, 4 are good. 4 are not good. So 4 are not good and 11 are good. 11 are good. Okay, then what is said here? All are not good. You have to select all from the not good category. All the 4 you have to collect from not good category. So that can be done in 4C4 ways out of 15C4 ways, right? 15C4 ways. The next 2 are not good. You have to select 2 from not good category and the remaining 2 from good category, right? So you are getting that as 4C2 into 11C2 by 15C4. The next, a card is drawn from a well shuffled pack of cards. What is the probability that it is either a spade or an ace? So which concept we have to use? Union, addition theorem. Are they mutually exclusive? No, they are not. What will that? Ace and spade will have something common there, right? So right there, P of A union B is equal to P of A plus P of B minus P of A intersection B. What is the chance for getting a spade? How many spades are there? 13 out of 52. So 13 by 52. How many A's are there? 4 by 52 is the chance. Then how many are there, how many A's are there which are spades? 1. So 1 by 52. Okay. Then fill that. Yes, 4 by 13. Then next, 3 students, A, B, C are in the running race. A and B have the same chance of winning. A and B have the same chance of winning. And each is twice as likely to win as C. Then what is the chance that B or C wins? What is the chance that B or C wins? Again addition theorem, but chances of A and B are same, but it's equal to twice the chance of C. Okay, then he's asking the chance for B or C winning. Chance for B or C winning. No chance is given there directly. Okay, they are saying that this is equal to this, but it is not given separately that P of A equal to something, P of B equal to something. We have to find out. P of A equal to, see that we have 3 events, P of A, P of B, P of C. He said P of A is equal to P of B, but P of A equal to P of B and equal to twice the P of C, 2 times of P of C. Then from this we need to get what is P of A, what is P of B and what is P of C, because we have to find out P of B union C, right? So how to get that? Yes, you have to use the axioms. Sum of all the probabilities equal to 1. So right there we know that P of A plus P of B plus P of C equal to 1. So P of A is as it is, or what we'll do is we'll write all in terms of C. Okay, 2 times of P of C plus 2 times of P of C plus P of C equal to 1. So P of C becomes 1 by 5. Then P of A, P of B becomes 2 by 5, 2 by 5. Then P of B union C is P of B plus P of C, because we are talking about winning, so one wins, the other will lose, right? So axiom 3, P of B plus P of C. Okay. Now we'll come to conditional probabilities. After covering all these, I'll give you from the MCQs. Okay, conditional probabilities. What does this mean? P of A by B. Probability of happening of A after the happening of B. Okay, probability of happening of A after the happening of B is P of A by B, which is written as P of A intersection B by P of B, provided the denominator value is greater than 0. And similarly, P of B by A, probability of happening of B after the happening of A is also P of B intersection A or A intersection B, both mean same. So P of A intersection B by P of A, where P of A is greater than 0. From this we'll get the multiplication theorem. Okay, if you just rearrange it, you are going to have the multiplication theorem. Okay, you can see from this multiplication theorem. Yes, if I take the second one, I can rewrite it as P of A intersection B is equal to P of A into P of B by A. Or if I take the first one, I can write it as P of B into P of A by B. So this is the multiplication theorem. Now comes the concept of dependent independent events. Okay, dependent independent events. I said that if happening of the first one is not affecting the happening of the other one, second one, then they are called independent events. Otherwise they are called dependent events. Now look at that, we wrote there P of A intersection B is equal to P of A into P of B by A, P of B by A. B by A. So B has the effect of A. B has the effect of happening of A. If B has no effect of happening of A, I can simply write it as P of B. Right? If B has no effect of happening of A, I can write that P of B by A as simply P of B. Okay? So in that way, I'll get this P of A intersection B is equal to P of A into P of B, or I can write it as P of B into P of A, because the second event has no effect of the first one. A by B is same as A, B by A is same as B. Okay, A by B has become A, B by A has become B now, because the second event has no effect of the happening of the first one. Okay. So write a note there. If A and B are independent, P of A intersection B is equal to P of A into P of B. If A and B are independent, then P of A intersection B is equal to P of A into P of B. But see that nowhere it will be mentioned that whether the events are mutually exclusive, whether the events are mutually independent or not. We have to check and we have to decide whether they are independent or not. Okay. So by default they are not mutually independent. Okay. Then we'll take the problems on this. Problems with one after the other in succession, with replacement, without replacement. Okay. Such words you'll get in these problems now. Yes, write the question. A class has 10 boys and 5 girls. 3 students are selected at random, one after another. One after another. Class has 10 boys, 5 girls. 3 students are selected one after the another. Find the probability that first 2 are boys and third is a girl. Second bit, first and third are of same gender. First and third are of same gender, and second is of opposite gender. How many students are there? 15. Yes. So 3 are drawn, but not at a time, one after another. Okay. So one after another in succession. So what is the chance that, what is it first one? First 2 are boys and the second and the third is a girl. Okay. What is the chance for first to be a boy? How many boys are there? 10. How many students are there? 15. Okay. So what is the chance for first to be a boy? 10C1 by 15C1 or 10 by 15. What is the chance for the second to be a boy? Is that mentioned with replacement? No. So without replacement only, right? So how many boys are there now? 9 out of 14. So 9 by 14. And third to be a girl. How many girls are there? Out of 13. So 5 by 13. So this is the case of dependent events now. You can see that the dependency is there. If it is a case of with replacement, then they will become independent. Okay. Then third, second bit there. First and third of same gender and second is of opposite gender. Suppose first and third are boys. First and third are boys. Then how will you write it? 10 by 15 and second is a girl now. 5 by 14. Third is a boy again. 9 by 13. So it can happen in another way also. So plus first and third may be a girl. So 5 by 15. Then second should be a boy. Second should be a boy. So 10 by 14. And third should be a girl again. 4 by 13. Yes. So this is a problem of dependent and independent events. The next, in a certain town, 40% have brown hair. 40% have brown hair. 25% have brown eyes and 15% have both brown hair and brown eyes. brown hair and brown eyes. 40% brown hair, 25% brown eyes, 15% both brown hair and brown eyes. Okay, 15, 1-5, full stop. A person is selected at random. A person is selected at random from the town. From the town. So first bit in that, if he has brown hair, what is the chance that he has brown eyes also? If he has brown hair, what is the chance that he has brown eyes also? Second bit, if he has brown eyes, determine the chance that he doesn't have brown hair. So it is related to which concept? Conditional probability. So how you write the first one? Okay, H will denote for hair, E will denote for eye. Okay, so how you are going to write it? E by H. What if he has brown hair? So H should be in denominator part. Okay, so what is the chance that he has brown eyes also? So P of E by H. Which is equal to P of E intersection H by P of H. What is P of E intersection H? He has given 15%. What is P of H? 40%. Yes. So now then come to second one. If he has brown eyes, then what is the chance that he doesn't have brown hair? So how you represent it? 1 minus P of H by E. Yes. You can write it as P of H complement by E. P of H complement by E, we can write it as P of H complement intersection E by P of E. Now see that this one, we have this formula, if you remember, not, I don't know. P of A complement intersection B is equal to P of B minus P of A intersection B. P of A intersection B complement is same as P of A minus P of A intersection B. How we are getting this? See this figure. Okay, this is A, this is B, this is A complement A intersection B complement, this is A complement intersection B, this is A intersection B. Okay, so from that Venn diagram you can observe that formula. From that you are going to get like this. P of H complement intersection E you are writing, no? So you can write it as P of E minus P of H intersection E by P of E. P of E by P of E separately 1. Done? Second bit what you are getting? 1 minus 1 final answer is 2 by 5. Are you all getting that as 2 by 5? Okay. So write some note. If A and B are independent, because sometimes in problems we have to use this. A complement and B complement are also independent. Second point, if A and B are independent, A complement and B are also independent. A complement and B are also independent. Third point, if A and B are independent, A and B complement are also independent. So all those proofs you can do that by using these formulas what I wrote just now, and De Morgan's law. De Morgan's law and this you can use and you can get those formulas. Okay, you can show that they are all independent. Okay, then take the next. 2 digits are selected at random from the digits 1 to 9. First bit, if the sum is odd, what is the probability that 2 is one of the numbers selected? If sum is odd, what is the probability that 2 is one of the numbers selected. 2 is one of the numbers selected. 2 is one of the numbers selected. Second bit, if 2 is one of the digits selected, if 2 is one of the digits selected, what is the probability that the sum is odd? What is the probability that the sum is odd? To which concept it belongs? Conditional probability. Yes, do that. Sum is odd. How many numbers are there? How many numbers are there? How many odd are there? How many even are there? 4 even, 5 odd. Okay? Odd is 1, 3, 5, 7, 9. Even 2, 4, 6, 8. Sum is odd. In how many cases sum can be odd? What is the answer there? 5C1? Sum is odd. 5C1 into 4C1. Why? Because 1 comma 2 sum is odd, 1 comma 4 sum is odd, 1 comma 6 sum is odd, 1 comma 8 sum is odd. Similarly, you have 4 more numbers. So 5 times of 4, you will get the sum as odd. Okay, 5 odd numbers clubbed with 4 even numbers will give you 20 cases where the sum is odd. So write there. Getting sum as odd. Okay, number of cases are 5 into 4, that is 20. Number of cases where we can get the sum as odd is 20. Then what is said? If the sum is odd, what is the chance that 2 is one of the numbers selected? Time 5. Yes, 2 comma 1, 2 comma 3, 2 comma 5, 2 comma 7, 2 comma 9. So 5 numbers are there in which 2 is one of the numbers, or 5 combinations where 2 is one of the numbers, right? So what is the answer then? Required probability is? Required probability is 5 by 20, which is 1 by 4. Total cases where the sum is odd is 20, 5 into 4. Of them, there are 5 combinations where 2 is one of the numbers. Of them, there are 5 cases where we have 2 is one of the numbers. 2, 1, 2, 3, 2, 5, 2, 7, 2, 9. So 5 cases are favorable. So required probability is 5 by 20. Then second. This is first bit, then second. Second. Okay, see the second case. If 2 is one of the digits selected, then what is the chance that the sum is odd? If 2 is one of the digits selected, what is the chance that the sum is odd? In which case it's 5. What is the required probability? Tell me final answer. 5 by, is that 5 by 9? If 2 is one of the digits selected, what is the chance that the sum is odd? In how many cases 2 is one of the numbers selected? 5. See? 2 is one of the numbers selected. That was the case when the sum is odd. Here no such compulsion is there, right? 2 is one of the digits selected. How many cases are there? 9 cases. 2 comma 1, 2 comma 2, 2 comma 3, so on, 2 comma 9. So 9 cases are there. Of them, okay, how many cases are there where the sum is odd? 5 cases, right? So what is the required probability now? 5 by 9. Okay. Now we'll see a few more, then we'll go to MCQs. Then write the next question. A problem in statistics is given to three students, A, B, C, whose chances of solving are 1 by 2, 3 by 4 and 1 by 4 respectively. 1 by 2, 3 by 4 and 1 by 4 respectively. Then what is the probability that the problem is solved? What is the probability that the problem is solved? What is the probability that the problem is solved? See that here, problem should be solved. There is no compulsion that all should do that. He should get the solution. Whether the first person does that problem or the second one or the third one or all. Okay? So, which concept we need to use here? 1 minus none. Okay? Probability of at least 1 is equal to 1 minus probability of none, I said. Or you can make use of P of A union B union C. Either this or this or this. Right? But this will become lengthy. So instead you can go to probability of at least 1 is equal to 1 minus probability of none, what I said in the beginning. Right? So use it. What is P of A given?
1 by 0.
What is the chance for the first person to solve the problem? 1 by 2. What is the chance for the second one to solve? 3 by 4. What about the third one? 1 by 4. Then what is the chance that they won't solve the problem? Because we need complements. Okay, P of A complement, P of B complement and P of C complement. 1 minus 1 by 2, 1 minus 3 by 4, 1 minus 1 by 4. They are the complements. Are these independent? If one solves, will it affect the other one? No. No, they are all independent. Right? So we can write that as 1 minus P of A intersection B A complement intersection B complement intersection C complement. Yes, here we wrote P of at least 1 is equal to 1 minus probability of none to solve that problem. Right? So it is nothing but P of A union B union C is equal to 1 minus P of A complement intersection B complement intersection C complement. Now see that A, B, C are independent. Just now I made you write the note. If A and B are independent, A complement and B complement are independent. Similarly, A, B, C are independent, then their complements are also independent. So we can write it as 1 minus P of A complement into P of B complement into P of C complement. So put those. So it will be easy when compared to doing that with P of A union B union C. It will become lengthier. There are 12 cards numbered 1 to 12 in a box. If two cards are selected, what is the probability that the sum is odd? First case with replacement, second case without replacement. Again start doing in the same way. Separate them odd and even numbers. Odd, even. How many odd are there? 1 to 12. So 6. Odd is 6, even is 6. What is the chance that the sum is odd? One after the other, with replacement, without replacement. First case is with replacement. Which concept you are using here? Conditional probability. 6 by 12 into 6 by 12. Sum as odd. What is the chance that the sum as odd with replacement?
6 by 12.
From odd, you can select 1 out of 6. That can be done in 6 ways out of 12. So 6 by 12. Then you have to select one, the other one as odd. One should be odd, the other should be even. Right? One should be odd, the other should be even. Then, so 6 by 12 into 6 by 12. So 1 by 2 into 1 by 2, so 1 by 4. Then second one. Second one is without replacement. 6 by 12 into 5, 6 by 11, because we have drawn the other card, right? So 6 by 12 into 6 by 11. Now we'll see Bayes theorem and related problems. Okay, in MCQs, however, we are going to get similar type of questions. Okay, Bayes theorem are the mutually exclusive and exhaustive events of the sample space. Okay, and A is some arbitrary event of that sample space. Okay, such that, see that here we have E1, E2, so on up to En are mutually exclusive and exhaustive events, and A is an arbitrary event such that A is contained in all union of EIs, and P of A is greater than 0, then the conditional probability P of EI by A is equal to P of EI into P of A by EI by summation P of EI into P of A by EI. Now see that here we wrote union of all EIs. It doesn't mean actually union. A is some event, okay, which is in common with all these, which cannot happen alone, which cannot happen independently. A cannot happen independently, all the other EIs. Okay, it is common with E1, E2, E3, so on up to En. Okay, so we wrote that they are all mutually exclusive and the exhaustive events of the sample space. A is some event which is in common with all these, which will not happen individually. It has to happen with E1, E2, E3 and so on. Something common will be there between A and E1, A and E2, A and E3 and so on. If it is in such a way, then the conditional probability is given, that is P of EI by A is equal to P of EI into P of A by EI by summation P of EI into P of A by EI. This denominator part is called as total probability. Write that. Denominator part is called total probability. So we'll do both the type of problems here, total probability and the conditional probability or Bayes theorem. Yes, write this one. In a certain college, we'll do only one or two, remaining we'll do from the MCQs, okay? In a certain college, 25% of boys, write it fast, 25% of boys and 10% of girls are studying mathematics. 25% and 10% are studying mathematics. The girls constitute 60% of the student body. First bit, what is the probability that mathematics is being studied? Second bit, if a student is selected at random and is found to be studying mathematics, find the probability that the student is a girl. Yes, when we need this Bayes theorem, see that, yes, here, like just I give an example. If suppose 3 machines are there, listen, 3 machines are there. First machine produces this much output, second produces this much output, and third this much. From that, some are defective, and from the third one also some are defective. If they are put there itself, then no need of using Bayes theorem. Okay, suppose all those defective items are put at one place, and after that, if suppose we picked one defective item from the dump and checking what is the chance that this is the bolt or this is the defective item produced by machine 1. Then I need Bayes theorem. If a student is selected at random and found to be studying mathematics, then what is the chance that it is a girl? Reverse. What is the chance that it is a girl? Okay? If girls and boys are separately, okay, and if you have the data, then no need of using this. If picked randomly and checking what is the chance that it belongs to girl or boy, then we need Bayes theorem. Okay? So write that. Girls and boys are given, right? Girls constitute 60% and boys constitute 40%. So P of G, or shall we write, better to write same representation for all to avoid confusion. Okay, whatever is the common point will denote with A and the remaining all will write with E1, E2, E3 to avoid confusion, better. Okay, and E2 represents girls and boys. E1, E2 represent girls and boys. Okay, then what is P of E1 given? P of E1 is chance for girls to in the student body 60%. So P of E1 is 0.6. Similarly, P of E2 is 40%. Now, what is the common point? Studying mathematics. Okay, A is the common point among all E1, E2, E3 and ENs, and among the students there. Okay, so let A be studying mathematics. Studying mathematics. So P of A by E1, P of A by E2, P of A by E1 is nothing but girl studying mathematics, boy studying mathematics, or mathematics being studied by girl, like that. Okay, so what is P of A by E1? What is the P of A by E1 given? 10%. Okay, P of A by E2 25%. So 25%. This is 0.1, this is 0.25. Okay, then what is said is, if a student is selected random and found to be studying mathematics, then what is the chance that it is a girl? Then what I have to find out? P of E1 by A. P of E1 by A, reverse. So which is equal to P of E1 into P of A by E1 by P of E1 into P of A by E1 as summation I am writing directly here, P of E2 into P of A by E2, which is equal to P of E1 is 0.6, P of A by E1 is 0.1 by 0.6 into 0.1 plus 0.4 into 0.25. 0.4 into 0.25. So we'll do the problems in a similar way. 0.06 by 1.06. What is maths being studied? We got second bit directly here. We wrote S. This is second bit, sorry. This is second bit. We went directly to second bit. But from second bit also you will get first bit. Denominator is considered as the first bit, total probability. Okay. Denominator is the total probability, so you can take the denominator as the first bit. Okay, now 10 minutes break. Start writing fast. Companies B1, B2, B3 produce 30%, 45%, and 25% of the cars respectively, it is known that 2%, 3% and 2% of the cars produced from B1, B2, B3 are defective. I'll repeat the question. Companies B1, B2, B3 produce 30%, 45%, 25% of the cars respectively. It is known that 2%, 3% and 2% of the cars produced from B1, B2, B3 are defective. What is the probability that the car purchased is defective? 30, 45, 25, 2%, 3%, 2%. What is the probability that a car purchased is defective? Second bit, if a car purchased is found to be defective, what is the probability that this car is produced by company B3? So one thing I'll tell you here, you can do directly with this. Yes, what is P of suppose B1, B2, B3 we take, or I said that we'll use same concept, same notations, E1, E2, E3. Okay. So P of E1, what is P of E1? What is P of E2 and what is P of E3? Cars produced by company B1, B2, B3. What is the chance? What is the chance given? And the 30%, 45%, then 25%. 30%, 45%, 25%. Then what he is talking about? Defective cars, right? So let A represents defective car. Then P of A by E1, the defective car produced by company B1. How many? What is the chance? 2%. Then P of A by E2, 3%. P of A by E3 is also 2%. Then see that what is said is, what is the chance that the car is defective? So we have to calculate first P of A, that is given by P of E1 into P of A by E1 plus P of E2 into P of A by E2 plus P of E3 into P of A by E3. Total probability you have to calculate and take the first by total, second by total, third by total, you will get that same. No need of the formula also. Okay. First by total will give you the chance for the first one. Second by total will give you the chance for the second one and so on. So calculate them separately so that you can get the answer easily in that. P of E3 by A is equal to, you will get P of E3 into P of A by E3 whole divided by summation of P of EI into P of A by EI. You have to take similar problems and practice because this will take much time. We cannot do more number of problems. So after this, we'll start doing some MCQs based on these. What is the total probability P of A answer? P of A is 0. No, P of A. P of A is 0. What is P of A? 0.0245. P of A. That is not P of A. What is P of A then? 0.2. 0.0245 is P of A. 0.0245 is P of A, and P of E3 by A is 0.2. You have to practice a lot. Otherwise, time will not be sufficient. So, up to this, I'll stop there. I'll start MCQs. You have to answer fastly. Okay? If a coin is tossed twice, what is the chance of getting at least one head? I want answer from all. Choices, options are 1 by 2, 1 by 4, 3 by 4, none. 3 by 4. Second, the probability of getting a number greater than 2 or an even number, greater than 2 or an even number in a single throw of a die. Even number or a number greater than 2. Which concept you will use? Addition theorem, P of A union B. Options are, I'll tell you, 1 by 3, 2 by 3, wait. 1 by 3, 2 by 3, 5 by 6, none. Will there not be anything common? Common will be there, no? So P of A plus P of B minus P of A intersection B. So what is the answer? What is the chance for getting greater than 2? Greater than 2. Then even number. Then calculate and tell me. 5 by 6. Number greater than 2 or an even number. Yes? How much? 5 by 6. The next. A bag contains 3 red balls, 4 white balls, 7 black balls. 3 red, 4 white, 7 black. The probability of drawing a red or a black ball. Red or black ball. Again, which concept we have to use? Addition theorem. Red or black ball. Answers, options are 2 by 7, 5 by 7, 3 by 7, 4 by 7. Yes. What is the answer? Is that 5 by 7? Then next, the odds in favor of drawing a king, the odds in favor of drawing a king or a diamond. The odds in favor of drawing a king or a diamond from a well shuffled pack of cards. Odds in favor, you know that odds in favor, odds in against. Odds in favor of getting a king or a diamond. Which concept you will use? King or a diamond? Addition theorem again. Is there anything common? Yes. Yes. So what is the chance for getting a king? 4 by 50. Chance for getting a king. So 4 by 52. Chance for getting a diamond? 13 by 52. Chance for getting king and diamond? 1 by. Yes. So what is the answer you are getting there? Then write it in terms of odds in favor. P of E colon P of E bar. P of E, okay, and P of E complement you have to write. Then with that you will get odds in favor. Odds in against, reverse order. Okay, P of E colon P of E complement. What you are getting P of E? 4 by 13. Then what will be P of E complement? 9 by 13. So what you will get? 4 is to 9. Yes, options are 9 is to 4, 4 is to 9, 5 is to 9, 9 is to 5. 4 is to 9. The next. The probability that a leap year will have 53 Tuesdays. 53 Tuesdays in a leap year. 53 Tuesdays in a leap year. Options are 1 by 7, 3 by 7, 2 by 7, 5 by 7. 53 Tuesdays. 1 by 7. How many days will be left after writing that 52 weeks in a leap year? 2 days. 2 days will be left, no? After forming 52 weeks, how many days will be there? So now 2 days can be arranged in or written in how many ways? How many are favorable for getting one more Tuesday from that? 53 Tuesdays, no? So write the combination and tell. Is that 2 by 7 or 1 by 7? 2 by 7. Monday, Tuesday, Tuesday, Wednesday. So 2 combinations will be possible in that. So 2 by 7. The next, the probability of at least one of the events A and B occurs. The probability of at least one of the events A and B occurs is 0.6. At least one, okay, of A and B. You know how to write it. Is 0.6. If A and B occur simultaneously with probability 0.2, simultaneously with probability 0.2, you know how to write it. Then P of A complement plus P of B complement is, options are 0.4, 1.2, 0.8 and 1.4. P of A complement plus P of B complement. What is the first value given? At least one is said. So P of A union B is equal to 0.6. What is the other value has given? P of A intersection B is 0.2. Then what we have to calculate? P of A complement plus P of B complement. Tell me. P of A complement plus P of B complement. 0.4. See that here. Wait. P of A union B is given as 0.0. P of A intersection B is P of A union B is 0.6. A intersection B is 0.2. Right? So P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B is 0.6 and P of A plus P of B will get then minus 0.2. So this will become 0.8 is equal to P of A plus P of B. But what I want is P of A complement plus P of B complement. Okay? So P of A complement, P of B complement, which is nothing but 1 minus P of A, 1 minus P of B. Okay? So 2 minus P of A plus P of B. We have that value as 2 minus 0.8. So 1.2. 1.2. Okay, then next one. For two events A and B, P of A equal to P of A by B, P of A equal to P of A by B equal to 1 by 4. Equal to 1 by 4. And P of B by A equal to 1 by 2. P of B by A equal to 1 by 2. What we wrote? P of A is equal to P of A by B equal to 1 by 4. P of B by A is equal to 1 by 2. Then see the options. A and B are mutually exclusive. A and B are independent. P of A complement by B equal to 3 by 4. None. A and B are independent. P of A complement by B, P of A complement by B equal to 3 by 4. None. So which option is right? Third option is P of A complement by B is equal to 3 by 4. 4 options which are right. Put the conditional probability formula and check which of these satisfies. Is this related to mutually exclusive? Not at all. We are dealing with conditional probabilities, right? Are they independent? Satisfying that P of A intersection B is equal to P of A into P of B? Okay, so you can tick that. Then see the other one. P of A complement by B is equal to 3 by 4. it is same as 1 minus P of A by B. So both answers are right here. Both the options are right here. Both are right. Because P of A complement by B is same as 1 minus P of A by B, which is given directly, which is nothing but 3 by 4. The next. A coin is tossed 6 times in succession. A coin is tossed 6 times in succession, then the probability of getting at least one head is 1 by 64, 3 by 32, 63 by 64, none. 63 by 64. Yes. 63 by 64. How? 1 minus, yes. 1 minus 1 by 64. The next, if P1 and P2 are the probabilities, if P1 and P2 are the probabilities of passing an examination respectively, then the probability of only one failing in the examination, ఒకటే fail అవ్వాలి. And see that the answers are P1 plus P2 minus 2P1 P2, P1 plus P2 minus 2P1 P2. Second option is P1 plus P2. Third option is P1 plus P2 minus P1 P2. None. First option. P1 and P2 are for passing. Then what is said? That is only one should fail. Only one should fail. So what is the chance? Only one should fail. What is the right one? How you are writing that? Only one. Only one means P of A passing, P failing, or P of A failing and B passing the examination. Okay? P1 and P2 they are given. Okay? So P of A, or I can write this as P of B, A minus P of A intersection B, right? P of A minus P of A intersection B. I gave these formulas. Then P of B minus P of A intersection B, like this. But see that you are given chance for the first one to pass is P1, chance for the second one to pass is P2. So I can write this as P1 plus P2, twice intersection is there. So 2 times of P1, P2. So first option is right. The next, a coin is tossed n times. A coin is tossed n times. The probability that the head will appear itself, the probability that the head present itself an odd number of times. A coin is tossed n times. The probability of the head will present itself an odd number of times is 1 by 2 power n options, 1 by 2n, 1 by 2, 4 by 13. 1 by 2 power n, 1 by 2n, 1 by 2, 4 by 13. Read the question. Sometimes the question will not be clear. You have to read those sentences again and again. What is said here? The head will present itself odd number of times, n times. In the first toss, the chance for getting one head, what is talking? One head, 3 heads, 5 heads, 7 heads and so on. One head, what is the chance? 1 by 2. Okay? Second time, what is the chance for getting one head? That is 2 by 4 becomes 1 by 2. Then third case, suppose 3 times. 3 times. And then if it is tossed 3 times, then 3 heads will be there, and one head, one head, one head. One head, two tails, one head, two tails, one head, two tails. 3 combinations will be there and 3 heads is also there. So odd number of times he is asking. So odd number of times we have 4 cases out of 8 cases. So therefore again 1 by 2. So similarly it continues for any case, Even if it is tossed n times, you are going to have the same answer. Generalize it. So 1 by 2 is the answer for that. Okay. The next. 2 cards are drawn from a pack of 52 cards. Find the probability of getting 2 aces. 2 aces. Answers are 2 by 52 C2, 1 by 221, 1 by 663, none. Getting 2 aces. 2 by 52 C2 options. 1 by 221, 1 by 663, none. 4 C2 by 52 C2, 1 by 663. 4 C2 value is 6, 4 factorial by 2 factorial, 2 factorial. So 24 by 4, 6a. Okay. So 6 by, you will get 52 C2 there. So option is 1 by 221, 1 by 221 or 4 C2 by 52 C2, it's right, okay. The next, if 2 balls are drawn from a bag containing 3 white, 4 black and 5 red balls, 3 white, 4 black, 5 red balls, then the probability that the balls drawn are of different colors. 2 balls are drawn from a bag containing 3 white, 4 black, 5 red balls. Then the probability that the balls drawn are of different colors. Options are 47 by 66, 10 by 33, 5 by 22, 2 by 11. Only 2 balls are drawn. Keep that in mind. Only 2 balls are drawn. 47 by 66. Yes, what is the answer? 47 by 66. So 6 cases we are getting there, right? 6 different cases we will get because we have 3 different colors. So 6 ways we will get, 3 into 2. 47 by 66 is the answer. The next, P of A union B is 0.75. P of A union B is 0.75. P of A intersection B is 0.15. Then P of A bar plus P of B bar. P of A bar plus P of B bar. Option are 0.9, 0.6, 1.25, 1.1. P of A union B is given, P of A intersection B is given. You have to find out P of A bar plus P of B bar. How much? 1.1. The next question. P of A equal to 0.4. P of A union B is equal to 0.7. And A and B are independent. Then P of B equal to P of A equal to 0.4. P of A union B equal to 0.7. A and B are independent. Then P of B equal to, options are 1 by 3, 1 by 2, 1 by 4, 1 by 5. A and B are independent. So you can write P of A intersection B as P of A into P of B. Use that concept. 0.5. Use the concept of independent events. How much? 0.5. Yes. The next, the probability that a number selected at random between 100 and 999, both inclusive, will not contain digit 7. the probability that a number selected at random between 100 and 999 both inclusive will not contain the digit 7, 100 to 999. Options are 16 by 25, 9 by 10 whole power 3, 27 by 75, 18 by 25. 100 to 999, it should not contain digit 7. C contain digit 7, then take 1 minus. Which contain digit 7 you take and take the complement of that. 100 to 999. So how many numbers are there? How many numbers are there? Both inclusive 900. As total numbers are 900 because both are inclusive. Then options are 16 by 25, 9 by 10 whole power 3, 27 by 75, 18 by 25. 18 by 25. How you are getting that? Yes, what are the favorable number of cases? For not getting 7. Okay, we'll take for getting 7. For getting 7, what are the favorable number of cases? Okay, see that? So, favorable number of cases by total number of cases, that is 900. The next, the probability that it will rain today is 0.5 and it will rain tomorrow is 0.6. The probability that it will rain either today or tomorrow is 0.7. Either today or tomorrow is 0.7. Then what is the probability that it will rain today and tomorrow? It will rain today and tomorrow. Options are 0.3, 0.25, 0.35, 0.4. Raining today 0.5, tomorrow 0.6, either today or tomorrow 0.7. So what is the chance that it will rain today and tomorrow? 0.4. The next, a die is rolled 3 times. The probability that exactly one odd number turns up among 3 outcomes is 1 by 6, 3 by 8, 1 by 8, 1 by 2. Die is rolled 3 times. 3 times. Okay? Getting an odd number. Yes. Die gada. Getting an odd number turns up among 3 outcomes is 1 by 6, 3 by 8, 1 by 8, 1 by 2. Someone said 1 by 8. Yes, getting an odd number among the 3 outcomes. 3 by 8. So with this we'll stop the MCQs. Okay. Then we have random variables. Okay. Random variables. If you remember, we have learned about different types of random variables, that is discrete random variable, continuous random variable, right, and their related properties. We have 2 types of random variables, discrete and continuous. But what is a random variable? What is a random variable? The real number which is associated with the outcomes of the random experiment. Which is associated with outcomes of the random experiment. It is called as the random variable. So 2 types of random variables are there, discrete and continuous. Discrete is the one which will take only integer values or finite number of values. Continuous is the one which can take all the possible values given in an interval. Okay, it can take all the possible values or infinitely many values. Then such is called as continuous random variable. For a discrete random variable, we have probability mass function. For a continuous random variable, we have probability density function. And you also have learned about cumulative distribution function, Pdf, Cdf, PMF. Okay, so just I'll write those properties. Probability mass function. Okay, it satisfies 2 properties. Okay, it is denoted with small f of x. small f of x. F of x should be greater than or equal to 0 and summation value should be 1. As we are using the word probability, it has to satisfy the axioms of probability, right? So we know that probability value will always be greater than or equal to 0 and sum of the individual probabilities equal to 1, right? So because of that, we'll have these two, that is f of x should be greater than or equal to 0 and sum of all the probabilities equal to 1, right? Then probability density function, it is also denoted with small f of x and it also satisfies the similar properties. F of x is equal to p of x equal to x. Okay, here also p of x equal to x. It also satisfies two properties, that is f of x greater than or equal to 0 and second one is minus infinity to infinity f of x dx is equal to 1. Dealing with discrete, there comes summation. When we are dealing with continuous, there comes integration. Okay, in both the cases, probability should be greater than or equal to 0, sum of the individual probability is equal to 1. In discrete sense, sum is given by summation. In continuous sense, sum is given by integration. That is the only change. Both are denoted with small f of x only. Cumulative distribution function is denoted with capital F of x. Cumulative distribution function. CDF. Okay, it is denoted with capital F of x, which we can write it as p of x less than or equal to x. X less than or equal to x. So it has the properties that p of a less than or equal to x less than or equal to b, I can write it as f of b minus f of a, and f of plus infinity is 1, f of minus infinity is 0, f of x is less than or equal to f of y when x is less than or equal to y, and f of x value is always greater than or equal to 0. I wrote there f of minus infinity, actually approaching minus infinity, actually it is that, okay. Approaching towards minus infinity, its value is 0, approaching towards plus infinity, its value is 1. Probability value always lies between 0 and 1. Then we have relation between Pdf Cdf, one with integration and the other with differentiation. Yes, f of x is equal to p of x less than or equal to x, which I can write it as minus infinity to x f of x dx. See that I wrote one relation with integration, the other I can write with differentiation. Okay, f of x is equal to d by dx of f of x. Relationship between PDF and CDF. If one is given, you can get the other one by using integration or differentiation. Then you have learned in random variables how to find out mean, variance. Okay, mean is equal to summation x into f of x, not NP. That is binomial. That is in binomial NP. Summation x into f of x. If x is discrete, random variable, integration minus infinity to plus infinity x into f of x dx. If x is continuous random variable, that is nothing but actually weighted average. Summation x into f of x, you have learned weighted average w1 x1 plus w2 x2 so on w1 xn by w1 plus w2 so on up to wn. The term will become 1. Why? We are dealing with probabilities. Sum of the individual probabilities equal to 1. So that's the reason we are not getting there 1. Denominator we are not getting. Summation x into f of x, integration x into f of x dx. That is mean. Then how to write variance? Variance. It is given by e of x square minus e of x whole square. E of x square minus e of x whole square. We wrote e of x, similarly we have to write e of x square, okay, which is written like this: x square into f of x with summation minus mu square. Okay, in the previous one I wrote e of x, which is nothing but mean mu, okay, since mu is equal to e of x. E of x. Okay, this is the case if x is discrete. And integration minus infinity to infinity x square into f of x dx minus mu square. So we can calculate mean and variance with this. Now how to differentiate whether it is a problem of discrete or continuous? If it is given in the form of table, or if you can form the table, then it is a problem of discrete, because discrete will have finite number of values, whereas in continuous you cannot form the table, you cannot write the table because it will have infinitely many values. You will be given a function with a specified interval, then it is a problem of continuous random variables. Okay? Then you have some properties like S, E of x plus y is equal to E of x plus E of y. E of xy is equal to E of x into E of y, provided x and y are independent. X and y are independent. Then E of ax plus b is equal to a into E of x plus b. Variance of ax plus b is equal to a square into variance of x. So this is what we have in random variables. Okay, this is in random variables. So we'll do the problems. Okay, I'll start even that binomial Poisson also I'll give. Then we can start all the problems at a time. Okay. So binomial distribution. S. Binomial distribution. When we need to use this binomial distribution, okay, we have some conditions. Binomial distribution. B of x comma n comma p is equal to p of x equal to x is equal to ncx p power x q power n minus x. Okay, when x is equal to 0, 1, 2, 3, so on up to n, only when it takes finite number of values. For the remaining, answer is 0. B of x comma n comma p is equal to ncx p power x q power n minus x. But you have to keep in mind that some conditions to be satisfied here, that write down there, number of trials should be finite, n should be finite, n should be finite, trials should be independent, trials should be independent, it should have only two outcomes, success and failure. It should have only two outcomes, success and failure. And probability of success P should be same throughout. Probability of success should be same throughout. Yes, in this P plus Q is equal to 1, because as I said just now, it will have only two outcomes which are disjoint. Probability of success, probability of failure will become 1, because we have learned that sum of the individual probabilities is equal to 1. Because here we have only two, success and failure, so their probabilities sum should be 1. So P plus Q equal to 1, or Q equal to 1 minus P. Okay, then its mean, here n and p are called parameters of binomial distribution. N and p are called parameters of binomial distribution, and here its mean is given by NP and variance is given by NPQ, and standard deviation is under root of NPQ. Under root of NPQ. Mean is NP, variance is NPQ, standard deviation is under root NPQ. See that here number of trials should be finite. When we go to Poisson distribution, in Poisson distribution, yes, when we use Poisson distribution, when number of trials are large or more in number, when n is tending towards infinity and probability of success is tending towards 0, then their product becomes a constant, a finite value. Okay, then we use this Poisson distribution. N tending towards infinity, P tending towards 0, then NP will become a finite value which is denoted with some lambda. Okay, P of x equal to x is e power minus lambda, lambda power x by x factorial, where x is equal to 0, 1, 2, 3 so on and 0 otherwise. Means it can take only positive values, for all the remaining values its answer is 0. Here lambda is called parameter of Poisson, and mean and variance are equal here, mean equal to variance equal to lambda, mean equal to variance equal to lambda. Okay, so tomorrow I may have to take 2 sessions, one for matrices and the other for probability, because many topics are still pending, because correlation regressions are there which are new to you. You did not learn correlations regressions. Okay, so tomorrow I should tell you about correlations regressions also. At least few problems will do of correlation and regressions. How to calculate the coefficients, correlation coefficient, regression coefficient, at least with one method I will try to tell you. Okay, and estimation, sampling distributions are there, so it will take time. So I need to take maybe 5 hours or 6 hours also. So I will see, one for matrices and the other for probability. Okay.